Reading Bohr's model from the reference table. So you have this model on the back of your reference table, and it explains what wavelengths are given off for different electron transitions in the hydrogen atom. So if we read this first problem, what is the wavelength of a photon emitted when the electron falls from the second energy state to the first energy state? So we're looking for the transition from the second circle to the first circle. There's a lot of different lines on this Bohr's model, so I think it's easier if you just trace around on the second circle and find all of the dots that could be present, and there's one right there. That's the only dot on the second circle, and it does in fact point to the first circle. So if we take that line and we trace it back, the wavelength is the number that's given to you. So wavelength is equal to 122, and then if you look at the top of the picture, it tells you that it's in nanometers. What type of electromagnetic radiation is it? Well, if you look down here, that 122 fell in the UV range, so the type of electromagnetic radiation is UV. If we do another problem here, what is the wavelength of a photon emitted when the electron falls from the sixth energy state to the second? So now I want my dot to be on the sixth ring, which is the outer ring here. And I come around and there's one dot right there and a second dot here. So which dot do we use? Well, it has to be pointing to the second ring. And the dot here on the left points to the third ring, so that's not the one we want to use. This dot here does point to the second ring, so we want to use this one. And we trace it all the way back, and we see that it is a wavelength of 410 nanometers. The type of electromagnetic radiation is visible, and you can abbreviate visible by doing vis if you would like. Now, because it's a visible light, we should be able to see a color. So now we're going to use the bottom part of our Bohr's model and relate this to color. The bottom, the electromagnetic spectrum, is done in meters, though, not nanometers, so we have to convert. Well, nano means times 10 to the negative 9. So if we take 410 times 10 to the negative 9th and we type that into our calculators, we would get 4.10 times 10 to the negative 7. And then we look at our electromagnetic spectrum. Where does 4.1 fall in? And it falls in between 4 and 4.2, and so it is violet in color. Number 3, what is the wavelength of a photon emitted when the electron falls from the fourth energy state to the second? So again, we want our dot to be on the fourth ring, and we want our arrow to point to the second. So if we trace the fourth ring around, we see we have 1, 2, 3 possibilities. This one all the way to the right is pointing to the first ring, and we want it to point to the second. The one in the middle is pointing to the second, so that's the one we'll use. And the one on the far left actually points to the third, so we don't want to use that one either. So we'll trace the middle one all the way back, and we see that we have 486 nanometers. So the wavelength is 486 nanometers. The type of radiation, again, is visible or vis. So we'll want to know what color that we're going to see. So we're going to take our calculators and type in 486, special button negative 9. It's always special button negative 9. And our calculator will tell us that that is 4.86 times 10 to the negative 7th meters. And 4.86 falls into the range of a blue color. So on the quiz and on the test, you'll be asked for the wavelength, which remember is the number, the type of electromagnetic radiation, and the color. So there'll be 3 questions reading Bohr's model.